Next, Latin square design or three-way classification, LSD. Latin square design is a method of experimental design. It is used to control variation in two directions of the experimental material, typically represented as rows and columns, which helps to reduce the experimental error. A Latin square is an n by n table filled with n different treatments, where each treatment occurs exactly one in each row and exactly one in each column. Example, 3 by 3 Latin square in numbers. See, in first row 1, 2, 3 different, right? First column 1, 2, 3 different. Second row, second column, check all the numbers exactly. The numbers available in only one time in the rows and column. Similarly for 4 by 4 A, B, C, D, right? We are taking. So any solution to the Sudoku puzzle we know, right, in a Latin square, with the additional restriction that the in 9 3 by 3 disjoint subsquares must also contains the digits 1 to 9 as clearly mentioned, right? A study to test yield of 4 varieties of wheat. Next example of Latin squares, right? We are talking about. A plot of land was divided into 16 subtotal, 4 rows and 4 columns. We will have the following Latin square design, right? 1, 2, 3, 4, A, B, C, D, right? Like that. Column, this is row. Next, order of a Latin square. So if it is n rows and n columns, the order is n. So if it is 3 row 3 column, the order of the Latin square is 3, right? Like that. Standard square, if in a Latin square the first row and first column has alphabet in alphabetical order. So if first row and first column, you check the first row and first column. If it is the alphabetical order, right? So our numerical value in numerical order. Numerical order means if starts with 1, 2, 3, 4, 5, 6, that is the order, right? Alphabetical, you know, A, B, C, D, right? If it is A, B, C, D, etc., like that, then that is standard square. First column and first row should be same like that. Similarly, if it is a number 1, 2, 3, 4, 5, 6, in that order. Suppose if it's starting with 4, 5, 6, 7 or 4, 7, 9, like that, that is the order, right? Ascending order. Then it is called standard. Right? Assumption in Latin square. The assumption made in Latin square design is that there are no significant interaction between treatments, right? And blocking factors, rows and column. So there is no interaction. So different type of what is varieties, whatever it is, numbers we are having, right? That is why there is no interaction. The effects of rows and columns are independent of treatments. Advantage and disadvantage. Advantage, LSD is the result in a three-way classification of analysis of variance. The analysis remains relatively simple even with missing data. Disadvantage, number of levels of each blocking variable must equal to number of levels of the treatment factor. So this is a square matrix, like, right? So otherwise you cannot use Latin square if it is not square. Suppose treatment is less than the variables blocks, or block is less than treatment, so you cannot use. Latin square model assumes that there are no interaction between the blocking variables, so that is also there, right? If there is any interaction between first row first element to second row first element, then you cannot use Latin square. Analysis of variance ANOVA procedure. So first Latin square n by n. N is capital N is number of items given in data, number of rows, number of column, which is equal to n, right? First step, defining hypothesis. There is no significant between columns. Second one, there is no significant difference between rows. Third one, there is no significant difference between letters, that is first yield, variety and treatment. Then alternate, there is significant difference, right? Opposite to null hypothesis. There is significant difference between rows and there is significant difference between letters. Step 2, prepare table 1, right? Calculation for ANOVA, right? As usual, right? Like two-way classification. So find row total, column total, then Ri square by n, Cj square by n, right? Here n only, right? Because n is same. This is a square matrix. Then find the grand total, sum of squares, and as usual correction factor, right? That's all, right? Next, find the total sum of squares, right? Using this formula ss minus g square by n. Then find the sum of squares, row sum of square, formula sigma ri square by n minus cf. Then column sum of square, sigma cg square by n minus cf. Then prepare table 2. Arrange the letters in the order, alphabetical order, right? So A, B, C, D. Then number of blocks. Then find same, right? Row total of Li. Letters, that means, right? So Li, first row total, second row L1, L2, L3. Then you have to find Li square by n and find the summation Li square by n. One-way classification, this is, right? Next, find the letter sum of squares using the formula, then error sum of squares, right? So total sum of square minus CSS plus RSS plus LSS. Then find the degrees of freedom, V1, V2, V3 and V4. Next, find the mean squares between the columns, MCSS, then MRSS, then MLSS and MESS. To prepare the ANOVA table, that is what we can prepare in the ANOVA table. So ANOVA, form the ANOVA table, right? Here it will come. Source of variation between rows, between columns, between letters, then error. So RSS, CSS, LSS, ESS, right? Then degrees of freedom, n minus 1. All row and column are equal, that is why n minus 1 and n minus 1. Then error sum of square, degrees of freedom, n minus 1 into n minus 2. Then mean sum of square, MRSS, MCSS, MLSS, MESS. Then find the ratio, F MRSS by MESS or MESS by MRSS according to the which one is the greater one. Greater one should be in the numerator and the lesser one should be in the denominator. Similarly for MCSS, F is equal to MCSS by MESS. First one FR, second one FC, then FL you can take, right, for the notation. Third one MLSS by MESS or MESS by MLSS. Then you find the conclusion. So how to find FC, FR, FL, right? Just notation, right? That is why we are giving RCL in the suffix of F. Next, conclusion, as usual, calculated value is less than tabulated value, accept, and calculated value is greater than tabulated value, reject, right? That's all. Next, comparison between RBD and LSD, two-way and three-way. RBD is a superior to LCD in many ways, right? And LSD can be applied only in special occasion, right? RBD can be applied for square or rectangle field. LSD can be applied only for the square field. RBD is available for wide range treatment. LSD available for the number of treatments is 5 to 10. RBD controls the effects of only one exogenous variable. Here LSD controls the effects on two exogenous variable, right? In RBD there is no restriction on the number of replication and number of treatments. LSD, the number of replication of each treatment is equal to the number of treatments, right? Because row is equal to column. ANOVA is more flexible. ANOVA is not more flexible. RBD is, in RBD there are no restriction for comparison of replication and treatment. LSD comparison of smaller number of treatment, the number of replication is inadequate, while for a large number of treatments the number has to be unduly increased. Next, reason for 2 by 2 Latin square design is not right. So consider n by n Latin square, degrees of freedom, SSE, that is error sum of square, ESS is n square minus 1 minus n minus 1 minus n minus 1 minus n minus 1. So that is equal to n square minus 1 minus 3n plus 3, that is n square minus 3n plus 2. So n minus 1 into n minus 2, right? For n is equal to 2, the error sum is 0, and hence MESS is not defined, right? So if it is there is no MESS, you cannot define f. So comparison is not possible, right? Reason for 2 by 2 Latin square design is not possible to compare. So hence 2 by 2 Latin square design is not possible, right? Thanks.